You know, when you've got products like ISA Server 2006, which is obviously a great firewall, it's pretty easy to get caught up with all the security capabilities of the product and not give a second thought to what else it can do. Now, one of the other great features of ISA Server lies with its ability to provide caching services as well. Now, we've already talked about what caching is in the very first video in this series, so let's quickly revisit that now. That way, everyone listening to this video understands what caching is and why it's important. And after that, we'll get stuck into the configuration. So here in our network here, we'll say we've got a user over here, is logged into their PC, and he or she fires up their web browser. So this user decides that they want to go and visit winstructor.com as it's such a popular website. Now, because this user's web browser would be configured to use the company's ISA server, the request for that website first hits the ISA server, and the first thing the ISA server does is it checks its own internal cache to see if it's previously been to winstructor.com. Now, if this is the very first visit to winstructor.com, then obviously it doesn't have any of the site details stored in its cache, so it's going to have to head off over the internet to the website and grab a copy of the page. So it's going to go off to winstructor.com on behalf of our user. It's going to get the page along with any graphics and videos and text and whatever data is required to get that page. Now, the ISA server obviously retrieves this page and it saves a copy of it locally here inside its cache, and then it sends it back to our user. So our user now is happy, he's got his page, but at this stage there's really been no real benefit to having ISA server get involved. Or has there? Well, there is a benefit, but it really shows itself when a second user comes along and tries to access the same page. Now, their request, like the previous one, is going to head off here to the ISA server. And again, the first thing the ISA server does is check its cache to see if it has a copy of the page that our user is requesting. Now, this time, of course, the ISA server discovers that yes, it's been there before, and it does have a recent copy of the default page, obviously because our user here went there a moment ago. So our ISA server now can send this page directly back to our user without having to head off to the internet to find the page. We've just simply delivered it here from the internal cache on the ISA server, meaning we never had to leave our network to fulfill the request. Now, this also means that we're going to save bandwidth because the page is being retrieved from the ISA server, not from the internet. And of course, whenever we save bandwidth, we also save money. So we're saving time and we're saving money. It's a double win. Now, this process, by the way, is something that we'd refer to as forward caching. We're caching objects locally to make things faster for our internal clients here. But there's also another version of this, what we'd refer to as reverse caching, which serves not to save our internet bandwidth, but to save local LAN bandwidth and to speed up serving content to external users, users that exist outside our network. So in a reverse caching scenario, let's say we've got a user somewhere out on the internet and they want to access our web server that we have sitting right here. So this external user, they fire up their favorite web browser and they're trying to hit our web server. So their request is first going to hit our ISA server, and it's the ISA server's job to go and fetch the content from our web server that obviously exists somewhere inside our network. Now, it's going to grab a copy of that page, it's going to save it locally here in its own internal cache before handing that page over to the user that requested it. Now, the next time another user externally, of course, wants to retrieve the same page, that request is going to hit our ISA server here, but this time the ISA server can return the page directly from the cache, and this time it doesn't need to go back to our web server again, and this can lighten the load on not only the web server, which might be useful if it's a busy web server, but it can also save our local LAN bandwidth as well, because it doesn't have to fetch that same content over and over again. And of course, because it's obviously one less hop down the network chain, returning that content back to the external user should theoretically be quicker. Now, there is one more benefit to this reverse caching scenario, and it becomes apparent if your web server happens to go down. You see, if you're actively caching the content here on your ISA server, then you can continue serving this data even when your real website's unavailable, just as long as that data is existing in the ISA server's cache, of course. Now, there's so many positive reasons to be using ISA server's caching abilities, and there's really not too many negatives. In fact, the biggest negative really is that in order to have caching work really well, you're going to want more RAM in your ISA server and more hard disk space. But let's get real. Hard disks and RAM, they're so cheap that they're almost paying us to take them. Alright, well, maybe they're not that cheap, but the cost of them is very, very low, and there's really no excuse not to have a decent server for ISA server anyway. So if you're going to take the time to put ISA server in, you'll probably find that the server is going to be cheaper than the software. And that's especially true if you're looking at the Enterprise Edition. Now, I will also point out is that you don't even have to back up this cache that we're going to implement, because if you do lose the disk that your cache is on, simply replace the disk and the cache will rebuild itself over time anyway. In fact, backing up the cache isn't even recommended, simply because as web pages come and go, what's hot today, in other words, the pages that people are requesting today and the ones being cached will probably be different tomorrow, especially on a dynamically changing website. So backing up the cache in most cases, it's rather pointless anyway. But in order to use the ISA server's caching functionality, you are going to need to ensure that the drive that you're putting the cache on is formatted with the NTFS file system. Couple of other points, this drive also needs to be a local drive as well, directly connected to the ISA server itself. You can't use a network drive for the cache. And finally, it's recommended that the cache be stored on a drive that's separate from the ISA server installation files and your operating system files for best performance. Now, the caching feature of ISA server takes advantage of the CARP protocol, which is a hash-based protocol that allows multiple proxies to be joined together in an array, so all of your proxies can work together and present a single logical cache. Now, your ISA server can also take advantage of hierarchical and distributed caching. Now, in a distributed caching scenario, we're going to have multiple ISA servers in an array, and all of these ISA servers will be actively caching objects, and our client machines, we'll say these are our client machines down here, will be able to use a cache that's spread over all of our ISA servers. Now, obviously, the key word there was an array, and you'd know by now that in order to even have an array, you need to have the Enterprise Edition of ISA server. Now, in a hierarchical scenario, you're going to have an ISA server that'll sit at head office, and we'll have other ISA servers at our branch offices, and any requests that we have coming from our users' computers, they're first going to be handled by the branch office ISA server, and if the data isn't there, then it's going to head off and contact the ISA server at head office for that data. Now, if it's not there, only then will that request head out onto the internet. Now, of course, there is a variation of what we're talking about, and that would be a hybrid of both our distributed and hierarchical types, where you might have a branch office ISA server, and that'll contact our head office, where we might have a bunch of different ISA servers in an array, all handling the traffic. Again, only the Enterprise Edition here supports arrays, so depending on how you want to structure your caching servers, that'll likely determine what version of ISA server you choose to buy. Now, since caching is not turned on by default, the first thing we'll need to do on our ISA server here is to turn it on. So in our ISA management console, we'll need to expand our server, LA ISA, and we'll expand configuration. And you can see here that the cache icon has this little red arrow on it indicating that it's not currently available, and this will be the same for you in a default configuration of ISA server. So we're going to select cache. And in the middle of our console here, you can see we've got 3 tabs: cache drives, rules, and content download jobs. In this video, however, we're only going to concern ourselves with these first 2 tabs, and we'll talk about content download jobs in a later video. So on our first tab here, the cache drives, this is where we're going to have to set up our cache and where it's going to live. So over on the right hand side of the console here, we'll click this link to define our cache drives, enable caching. Now this is going to pop up a new window here showing us the drives that we currently have available that we can use as a cache. And in my case, I have 2 drives, one of which I've specifically left for the purposes of caching, and that's my D drive. Now if you only have 1 drive, that's fine, but for performance reasons, we're going to select our D drive, and then we'll need to set a size for our cache. Now you can play around with numbers here to determine how much you want for your cache, but it really comes down to how many users you have and how much disk space you have to play with. But since you probably have a lot more disk space than users, as a general rule, Microsoft recommends around 4 gig for 500 users and around 10 gig for 1,000 users or higher. Now since I've got a dedicated disk here anyway, I'm going to set mine to around 10 gigs. So this value here is in megabytes, so that'd be 10,240, and we'll click set. Now if you do make a mistake, you can click on the reset button, and that's going to change this size straight back to 0. So let's just set it again to 10,240, and we'll click set, and then we'll click OK. Alright, as you can see, we'll need to apply this change. We've done this many times, so we'll click apply. And this time we will need to restart our firewall services. Now we do have 2 options here. We can save the changes but don't restart the services, or save the changes and restart the services. Obviously we will need to restart them, so we may as well go with the bottom option now. We'll click OK. And our configuration's been changed. And now that our cache has been created, let's verify that. We'll click on start. We'll go to my computer and then our D drive. And sometimes this can take a few moments to appear because obviously our firewall service has been restarted. And there you go. Now we can see we have this single folder here called URL cache. And inside here, we'll expect to find 1 single file. And of course, it's around 10 gig in size. So that's how ISA server does it. This cache here always will be 1 single file that's going to take up the space of whatever you set it to be. In my case, that's 10 gig. Now once this file is full of cached objects, it's just going to overwrite them as needed, and it'll do that depending on a formula that it will take into consideration things like the actual expiration date of the objects and how many people are using them and their size. Now another point is, should you want to delete this file, you will want to go into the services console and stop the Microsoft firewall service on this server before deleting it. But why would you want to do that anyway? Well, it's not likely that you would want to delete this file, save perhaps maybe you think it's been corrupted or you're having problems with the cache and you want to remove the file. Anyway, to delete this file, all you need to do is stop the Microsoft firewall service, then come in here and delete the file. Don't worry about recreating it though. ISA server will do that automatically once you restart the Microsoft firewall service. Alright, if we go back to our ISA server management console, you'll also notice here on the left hand side that our icon now has changed. We've no longer got that downward pointing red arrow, so we can tell at a glance that caching now is turned on. But if you do want to stop it from running, you can now come over here to the right hand side in our task pane and then choose disable caching to turn it off. Okay, so now this ISA server now has a cache set for it, so it can start caching data. But what will ISA server actually cache? Well, the answer to that question is to be found on our next tab, the Cache Rules tab. So here you can see we've got 2 default rules for caching. Our first is to cache data that we download from Microsoft Update. And that's quite a smart rule to have in place, really, something which is new in ISA Server 2006, by the way. Well, actually, that's not entirely true. It was available in ISA Server 2004 with Service Pack 2, but it was an optional feature that you had to turn on. So it's good that this is here by default now. And think about it. Whether you have 10 clients in service in your company or you've got 10,000 of them, updating each of them with the latest service packs and patches and so forth is a rather data-intensive exercise. Now sure, technologies like Windows Software Update Services, that exists to help distribute these updates to your machines, and it also helps you to save bandwidth by only downloading those patches once. But what if you don't have anything like that in your organization? Well, although you really should deploy Windows Software Update Services anyway, I'm a big believer in that product. Having a rule like this here is a pretty good idea. So let's take a closer look at it. We'll right-click on it, we'll choose Properties. We can see here that this rule is currently enabled, but we could easily disable this rule if we like by simply unchecking this box. On the To tab, this is where we'll see what this rule is applying to, what it is that we're targeting specifically. Now it says here we're applying to the Microsoft Update domain name set. So if we select that and choose Edit, it's going to show us all of the sites that this domain name set consists of. So any data that's coming from any of these locations here, things like windowsupdate.com, update.microsoft.com, and so forth down the list, any files coming over the internet from these sites will be cached. Now on our next tab we have the Cache, Store and Retrieval tab. This is set to only retrieve data from the cache if there's a valid version of the data in there. If not, then head off to the internet and fetch it. So basically what this is saying is, check the cache. If the file's there, and it's a current one, then give that one to the clients that are trying to update files from Windows Update or Microsoft Update. Now if it's not there, then head off to the web and download it. And of course, once that file is downloaded, it'll then be stored in our ISA service cache, and the next time a client requests that file, we should be able to deliver it from here and not have to go out to the internet again and get it one more time. That'll save bandwidth and time for each occasion that we need to get that same file again. Now we could also change this so that if any version of the object exists in the cache, then we'll give that to the client. Otherwise, we'll go get it from the internet. And finally, if any version of the object exists in the cache, then give that to the client. Otherwise, we'll just drop that request altogether and we won't go out to the net to get it. Now at the bottom here, we can choose to never ever store any content in the cache. And I want to remind you though that up the top here, just remember that this is only for the Microsoft Update cache rule. This isn't for all of our data. So if you were to choose no content's ever going to be cached, this is for this rule only. Now if the source and request headers indicate that there is data to be cached, we can also choose to cache dynamic content, and this means that our ISA server will cache objects even if they've been marked not to cache them. We can also cache content for offline browsing, we can cache that, and content requiring user authentication. And on the HTTP tab, we've got a few more options. Here we can also set the time to live for objects as a percentage of the content age. So when we download objects, for example, an image, a picture, it'll be saved in our cache. Now if that picture has an expiration date on it, then our cache will only cache it for up to 20% of the expiration date. Now if there's no expiration date on the object, then it'll be subject to the values that you see here below, which of course are to cache it for no shorter than 15 minutes. So that means if we download that picture now, then at least for the next 15 minutes, we're going to dish out that same picture from the cache. We're not going to go out to the internet and get another copy. And we'll do this for up to 1 day. Now these values of course can be changed to whatever you like, and note that if we check this box down the bottom here, we're able to apply these settings to all content, including those that have expiration dates. So checking this box here is going to override an expiration date that's set on the content itself. Now our last tab is the Advanced tab, and here we can set a maximum size of objects that will cache, and it's not turned on by default. And you'll see here that we will be caching all SSL responses. Now the other rule we've got here is our default catch-all rule. Now whereas the previous rule, the first rule here, only applied to those domains we saw for Microsoft Update sites, here with this rule it applies to any network. Now this time though, we won't go through all the details because all the settings are the same, so let's just right click and choose Properties. And if we simply scroll across this window, you'll see that it's applying to all networks. We'll be caching HTTP and FTP for around 20% of the expiration date, and FTP with a maximum of 1 day, just like with our Microsoft Update rule. So as it stands right here, using our default rule, caching is enabled for HTTP and FTP objects regardless of where they're coming from. So simply enabling caching, like we did at the start of this video, was enough to start caching everything HTTP and everything FTP. But these rules here are your baseline, so if you want to add other places to cache with your own specific settings, we'll just come over here to the right hand side in the Tasks pane. We'll choose the top option to create a cache rule, and that's it. Now we'll come back to that in a moment. Firstly, I do want to point out another couple of options that we have for our cache. So over here on the right, we're going to choose to configure cache settings. Now this defaults here to the General tab, which really doesn't tell us much, only how big our cache is, and a reminder that caching is only enabled when you have your cache set to a value that's higher than 0. So let's click on the Advanced tab here, and this is where we can configure how long we want to retain items in our cache. So our first option here is to cache objects that have an unspecified last modification time. So what does that mean? Well, when an object is fetched from a web page or an FTP site, the object in many cases will have a last modified flag. In other words, a value that tells ISAServer when the content was last modified. So this setting here is saying that if the object doesn't have a modified flag, we're going to cache it anyway. We're also going to cache objects even if they don't have an HTTP status code of 200. And a 200 status code simply means that the request was fulfilled, or in other words, the attempt to get the data that we just requested was successful. So this setting is the opposite of that and simply says, well, if we get another status code other than 200 when we fetch content, we're going to cache that as well. Now we'll allow our maximum size of our URL to be 12,800 bytes. That's the maximum size we'll allow a URL to be cached in memory. So anything larger than that won't be cached in memory, but you can certainly change that if you like. Now next, if there's an object inside our cache which has expired and the website can't be contacted to refresh the content, then the default is to simply return the expired object from our cache to the client even though it's expired, but only if these other conditions here are also met, including the time to live being less than 50% of the original, no more than 1 hour old, or not using more than 10% of our free memory. Now there will be certain content that you probably don't want to cache, and searches using search engines like Google or regular updated sites like news sites come to mind. Why? Because you typically want searches to be unique and fresh, and news sites, well, they can change several times a day. So let's see how we can implement cache rules for specific sites. So let's use Google as the example here. Let's click on Create a Cache Rule, and this starts up the new cache rule wizard, where firstly we're going to be asked to provide a name for this rule. So I'm going to call mine Don't Cache Google, and we'll click Next. Now the next step here is to define our destination where this rule is going to apply. So we'll click Add. Now at the top we're going to click the New drop-down box and we'll choose URL set. Now we'll need to give this URL set a name. I'll call mine google.com, and then we'll click Add. And for the site, of course, we're going to enter in www.google.com. And look, you can give this a description if you like, and although I'm a stickler for documenting everything, this one here is pretty obvious what it's for. But if it's an obscure site you're preventing from being cached, I'd strongly encourage you to fill this in. Alright, we'll click OK, and we'll expand URL sets. We'll choose google.com. We'll click Add, and then we'll click Close. Now we'll click Next. Okay, and now we need to define how ISAServer will handle a request for the page from google.com. Now we've got three choices here, and as the screen says, we'll be retrieving the requested object from the cache, which in our case will be google.com's searches or homepage, of course. Now the default here is to only grab it from the cache if a valid version of the object we're requesting already exists in the cache. If it doesn't, we'll go get it from google.com. Now we could retrieve the object from our Isoserver's cache if it's there, regardless of whether it's valid or not. Again, if it's not there, go fetch it from the web server at google.com. And finally, we'll retrieve the object from our Isoserver's cache if any version of the object exists there. If it's not there, we won't go and get it. We'll just drop the request and the user's simply going to get an error in their browser. Now, on the surface, it doesn't actually look like any of these are exactly what we're after. After all, we want to prevent Isoserver from caching anything from google.com. Well, truth be told, actually either of the first two are going to do us fine. Obviously, the third one's no good for our example because we do want to allow people to get to Google. We just don't want to cache it. Well, the first and the second rule specify that we will get the Google homepage from our cache if it exists, which of course it shouldn't. So the first part of our message really doesn't apply. The second part says it'll go fetch the content, and of course we do want that to happen. So I'm just going to leave the default at the first one here. We'll click Next. And right here, this is what we're looking for, the cache content settings. Now the default here is to cache the content if the source and the request headers tell us to cache it. But we're going to change this to the top option here, to never cache any content. In fact, if we just click on the back button here for a moment and change this to our second option and click Next, you'll notice here that we've got the same setting. So in this case, either one of those would have been fine. So we're going to set this to never cache the content. We'll click Next and we'll click Finish. Now before we apply this change, one thing I should point out though is that if we double click on google.com here, you'll notice obviously that google.com is the only URL in this URL set, and that's fine. It's going to work for the purposes that we set it up for. But a better option would be, let's rename this from google.com to something like search engines. And down here we'll click Add, and then we'll add in other search engines like www.bing.com, and we could also add in www.yahoo.com and so forth. So now let's click OK, and I'm quickly going to double click on this column here, Don't Cache Google, and I'll change this to Don't Cache Search Engines, just so our naming convention is all good there. And by the way, one other thing I should probably point out, let's double click on that again and go to the To column. You'll also note here that our URL set has changed, and that's been renamed from google.com to search engines. So when we changed that here, that also changed the name there. All right, now it's time to apply this change. And now that rule's in effect, and we're no longer caching anything to do with those three search engines. Actually, there is one other thing I probably should point out. Let's double click on our rule again, and let's go to our To tab, because there's one thing that I didn't show you guys, and that's how to add in an exception. Now, even though we're choosing not to cache any search engines, well, at least not the three we've specified, we can make exceptions to that rule. So we're going to click Add here, and like before, we're going to add in a new URL set. Now I'm going to call this one Allowed Search Engines, and we'll click Add, and let's say for argument's sake that we'll say Bing has a subdirectory called Bang, and we do want to cache anything that comes from that subdirectory. So we can simply enter in the URL, we'll click OK, and now we'll select the URL set that we just created, the Allowed Search Engines one. We'll click Add and then Close. And what we have now is we have the search engines that we won't cache. So none of these Yahoo, Bing, or Google search engines will be cached, but in our exceptions list here, we're going to make an exception for the Bang subdirectory of the bing.com domain, if of course such a subdirectory even exists. Alright, well, we're going to click on OK, and again we'll need to apply that change. So our rule now is live and in effect. But note over here on the right hand side of our console in the task pane, we can also choose to edit, we can delete or disable any of the selected rules. And some of you might have already noticed that these same options are available if we right click on the rule itself. Now down the bottom here we can also choose to export and import the cache rules, and that works in exactly the same way as backing up our firewall configuration that we showed you in an earlier video. So I'm not going to bore you by going through that again. But just as we said in that video, when you do back up your configuration to an XML file, just make sure that you back it up onto a network share or a different disk, just in case this one goes down. That way you still have your saved copy. So in this video, we've taken a detailed look at the caching capabilities of ISAServer 2006. Now, using a cache really does speed up viewing websites the second time around. After all, the data needs to be retrieved to get it into the cache first. Now imagine enjoying the speed benefits and bandwidth savings you'll have by configuring the cache component of ISAServer when you multiply the savings by the number of users you have. So I'd strongly recommend that you take a look at the ISAServer cache component and put it to work in your company, and I think everyone will be glad that you did. So we hope you've enjoyed this video, and we'd like to thank you for watching.